Hey, Gus, real quick, are you guys seeing reservations? You were, was it Ralph seeing reservations for Tempo when they're made?
No, I don't, but Ralph does. I think
okay.
Ralph should.
Oh, okay.
Yeah, you should be emailing. It's like book buyer. I can email. I'll reply to you on your email, Pete, if with his contact info, if you don't already have it.
With whose?
Ralph's for Temple
Oh no,
reservation.
I've made reservations before, but you never get a response back. You know, it says that you submit it and it goes off to Never Neverland, and I never see anything that comes back on it.
That sounds like Ralph.
Yeah. Yeah.
Not that I'm
received the
expecting a
reservations.
response. I didn't know what the normal protocol was for that.
Yeah, I don't receive them, but I just help out Ralph when he can't go. I just let him know, well, I'm going, so I'll open up, and then he'll let me know approximately how many people are showing up. One person, 10 people, or he'll let me know. But I don't get that information.
I got you. Thank you.
And to go ahead and get started for the evening, got actually a good number of people on this one. So welcome everybody. This is the Tucson Astronomy Association's Astronomy Fundamentals Special Interest Group, otherwise known as AFSig. That's always a mouthful. So this month we have two presentations for us tonight. The first presenter up will be Pete Hermes, who is going to give us kind of a condensed overview of the astronomers that came after the Roman astronomer Ptolemy, or Greek, one of the two. But before Copernicus, and we're going to try to condense all of that, the entirety of astronomy during the Dark Ages into, I think, about 35 minutes. So we're going to speed run this.
Connor, I'm going to be brief because I know we want to get to your presentation. So there's a lot of repetition in mine, and I'll point that out. So if I start busting 30 minutes and I'm not on if I'm not on slide 12, let me know.
It'll be fine. I'm not worried about the time. And then after that, I will be giving a kind of a visual walkthrough of the Celestron hand controller for Celestron Go-To telescopes. There's some caveats and some details about that. We'll get more into that later. But without any more waiting, Pete, turn it over to you.
Thank you, Connor. Thank you, everybody, for your attention for my presentation. I certainly appreciate the opportunity to present before this august group once again. Anyhow, for those of you that were with us last month, I provided a presentation on Ptolemy. And so I decided, well, what's the next logical choice just to move through history, basically to cover the astronomers that very few are known. And I mean, they certainly weren't known to me. I mean, I was aware of, Ptolemy and maybe one or two before. And of course, you get to Copernicus and move on through, you know a lot more of those names. So some of these will be some new names for y'all. I'm going to try to abbreviate some of them. I don't want to butcher them. Most of them are Muslim or Arabic names or Indian names. And certainly my pronunciation is probably going to be a lot poor. So, and by all means, if anybody has any inputs, go ahead and bark right in. I don't mind the interruptions, a question or whatnot, and especially if I miss any of the notes down the bottom. I don't keep the bottom of my screen going, just concentrating on the charts. Anyhow, like I say, this is after Ptolemy. Ptolemy passed about 170 Common Era. The first of the astronomers I'm going to talk about will start about 300 years after Ptolemy passed. And of course, we're going to carry this up into about the 13th century. And we don't have Copernicus showing up until the late 15th century. So there are a couple holes. There's a couple of overlaps. And you can see there. Oh boy. There we go. Okay, so you can see some of the dates. I've got the left side of my screens blotted out a little bit. So there we go. These are basically the dates that these folks were active. Aryabhata, Al-Razmi, I'll refer to him as Musa because it's a lot easier. Al-Kindi, El-Mahriti, Omar Khayyam. There'll be more about this later too. I think some of you may be familiar with Omar Khayyam, but not from the standpoint of being an astronomer, or maybe you are. Beira, and then Nasir al-Din al-Tusi, and I'll refer to him as al-Tusi. You can see the dates of these, the birth and the death dates for each of these folks. And like I say, Aryabhata was born about 300 years after Ptolemy passed. And then we have, you go down to the end, Tusi, you can see that he passes. And it was about 200 years later when Copernicus is born. So there's a little bit of lapse. You'll see some lapses in here. There's a couple of overlaps, especially when you look at Musa and Al-Kindi. There was about 40, 50 years that they overlap. Not that they necessarily interacted. I suspect, though, and may mention this, Al-Kindi, I think, was aware of Musa's work and actually either enhanced some of it or used it as a basis for some of his. And then a little bit of overlap between Khayyam and Bahura, but here again, they may have been in two locations. Similar to the discussion we had about Ptolemy last month, there's a lot of information that isn't known, especially with respect to personal information, whether or not, and these are all men, sorry, although I'll make mention of one daughter that actually supposedly became an astronomer, which was kind of astounding. But these are all men, and I just lost my train of thought. Golly, these are all men, that had, throughout time, we're in different locations, but still, for the most part, with the exception, and I'm trying to remember if it was, I think it was Mariti, we're pretty much in the southwestern Asian part of the continent, India, the Islamic world, and in the case, I think it was Mariti, he was an Arab Muslim, and I'll talk about this, but it was actually in Spain at the time in the Andalus. So anyhow, I know what I was trying to do, just get these going. Okay, so these are the basic dates that these folks were around. Okay, the first one, Aryabhata, was an Indian mathematician and astronomer. One thing too, and this will be a common theme pretty much with just about all of these men, is that, yeah, they worked in astronomy, but really the bulk of their work was primarily in mathematics, arithmetic, and other areas. In the case of Aryabhata, primarily a mathematician and astronomer, and if anything, the bulk of his work probably was with respect to work in mathematics. He was born in the Asmaka, or was now known as common day Patna, India. I believe is up in the northern regions, northwestern regions of India. One of his, here again, little known about him, other than when he was born, when he died. But here again, with a lot of the almost ancients before the Middle Ages, a lot of these folks, we know them principally from their works, not necessarily anything specific about them. I know what I was referred to before with respect to whether or not they were married, how many children they had, ancestry predating, and down through their family trees. We know very little about their personal information. Anyhow, we have Aryabhata's primary work, which was probably put together by 499, just prior to the start of the 6th century. Interesting thing, and you'll see there's a little front page of it. Of course, that's a modernized cover version, but this was written in verse. Not typical narrative that you see a lot of scientific or a discussion, but rather written in verse, and that's how he published a lot of his information. Anyhow, this particular work dealt with phonetic number notation for the most part, as far as trying to design a number system that was common and could be spoken between individuals. Here again, we have some writing, but it's very little. He also worked on algorithms for square and cubic roots, was able to make a determination of pi. And this is something throughout history you'll see, especially with a lot of the folks that are involved in mathematics, trying to determine an accurate number for pi. Of course, we know it's a lot longer, but still pretty good accuracy here, as far as 3.14. Pythagorean theorem to derive tables of signs, and getting into his astronomical work, prediction of solar and lunar eclipses. We already had that with Ptolemy. I suspect here what we have is a little bit, whether or not Aryabhata had the works or something written down from Ptolemy as far as expanding on some of his work. And the one thing he was able to make determination, this was a little bit new, is the fact that the Earth rotates on its axis. This was his postulate, which accounted for the heavenly motion. It was not necessarily that the sky moved around, but pretty much confirmation. Well, I shouldn't say confirmation because it wasn't subject to any pure scientific process. And then also the moon and planets shine because of reflected sunlight. So these last two things are pretty significant with respect to astronomical theories or postulates that Aryabhata put forth. Okay, moving on in through history. Muhammad Musa I'm going to just call him Musa. I already had his name earlier. Anyhow, this is a pretty significant individual. We're going to see that some of his work formed a basis for some of the individuals that will follow on in my presentation. He was a Persian polymath, and he was from Khwarazm, south of the Aral Sea. Of course, you can see there's a similarity between where he resided and his name, where he was born, which is typical amongst a lot of the individuals, especially in the Muslim world. Polymath, he just covered a lot of different areas. You can say in this particular case, he conducted works here again in mathematics, astronomy, and geography. Polymath is merely referring to an individual's wide berth of expertise or what they worked in. Probably one of the more significant things, and this is a leadership position that Musa had, was appointed head of the House of Wisdom, which was the library in Baghdad, basically one of the first, the next largest library after Alexandria, and became well known. This was created in 820. It was pretty much in the center of the government there at the time, in the Persian Empire. Most of the works he did, centered around that 7 years prior to his appointed position at the House of Wisdom, and then for the next 13 years after. Of course, then he passed 17 years later. Two major works from Musa, one here, again, dealing in mathematics, or specifically a treatise on algebra, and then one on astronomy. And those two works, the first one dealing with some of his mathematics work, you could see the title going across. Not even going to try to pronounce it, but basically the title, somewhere in that title, and you can see it in the word right after Hisab, algebra, and pretty much define that. This compendious book on the calculation by completion and balancing. That's the closest literal translation. But anyhow, it's practical uses of algebra in problem solving and everyday usage. And this is where we have mathematical processes applied to common everyday, I shouldn't say common everyday, but practical uses. For instance, in the case of agriculture, using algebra to be able to calculate certain things and apply it in agriculture, apply it in family businesses, apply it for inheritances and how those would be handed down from one generation to the next. He also conducted work in developing linear and quadratic equations, and then mensuration, measurements, determining volumes of various solids, deriving the formula for that, and an application in everyday life. With respect to his astronomical work, a couple of significant things that Musa worked on was calendar and astronomical calculations. Back then, and you'll find this is true of most of these gentlemen, they tied a lot of their work into being able to construct calendars that could be carried one year to the next. And you'll see later there's further refinements where the accuracy of some of these calendars actually carried into the 20th century. Anyhow, original tables for the movements of the sun, moon, and 5 known planets, an enhancement or next step beyond Ptolemy in this particular case. And then going back to some of the math, other works in trigonometry, sine and cosine tables, tangent tables, which were a big thing then. Geography, one of the things I talked about with respect to Ptolemy last month was one of the things he was involved in geography, and as far as being able to use a coordinate system for defining the location of various cities. I think Ptolemy had worked on a catalog of somewhere up between 5,000 and 8,000 cities. And basically this was done again, but of course in the context and adding in the Arab world, India, and to a certain extent, some locations in the Far East. We don't see a lot of movement or a lot of travel from the Far East, but it's starting to occur. It's starting to happen. Certainly, people in this area are well aware of, in the Persian Empire, of the existence of other organizations, empires out to the east. And then developments and enhancements in astrolabe and sundial construction. Moving on to our next person, Al-Kinde. Here again, 801 to 873. So we had a little bit of a lapse between the previous couple hundred years. He was an Arab Muslim. philosopher, another polymath. You can see mathematician, physician, and music theorist. Which, pretty much you look at all these different areas that Al-Kindi was involved in, it pretty much defines what a polymath is. He was born in Khufu, Iraq. In the case of Al-Kindi, and certainly in the case of most of these individuals, their background was such that they had certain advantages. And I'm not saying they're all the same. In the case of Al-Kindi, he was born into an aristocratic family. So certainly he would have an advantage with respect to education and learning. Being in Baghdad, being in, probably for all intents and purposes, at that time, it wasn't a true metropolis, but probably a metropolitan area with respect to a concentration of people, concentration of learning centers. We don't see, we're starting to see at this point, and for the next 400 or 500 years, starting to see the development of learning institutions. Whether or not you want to call them schools, we certainly could, and I'm sure many people have done that. And interesting sidelight with respect to Al-Kindi, he was a very capable calligrapher. I'm sure it was one of those little skills he learned when he was growing up in his aristocratic family. House of Wisdom. This was a center of learning in Baghdad. And one of the major things that took place, and here again, this is something that all these individuals will talk about tonight or discuss or involved with, was taking, prior works, in this case, translation of Greek philosophical and science texts, certainly translation of Ptolemy's work, and going beyond that to a certain extent, trying to make other observations, increase the accuracy of the information, and some of the projections with respect to the movement of various bodies in space. He championed the Hellenistic and peripatetic. And peripatetic, basically, makes reference to, Aristotle's philosophy, and peripatetic specifically refers to walking around. And it's not that it's the kind of philosophy where you learn by walking around and looking at things. Best I can determine, I'll certainly take any inputs on this from anybody if they're more familiar with this, but my understanding is basically they didn't sit around at a fixed location, but would rather move around and discuss matters and teach and learn. So I don't know what the advantages might have been to that, but that was the method under which some of this teaching and learning occurred. In the case of Al-Kindi, he had a fairly large volume of work, hundreds of original treatises and a lot of different topics. You can read them there. And still, Al-Kindi, like some of his predecessors and those that followed up until the Middle Ages, there's still a heavy influence of astrology. I'm not saying so much that these individuals continued to develop that particular area, but there was certainly tie-ins with respect to astrology. Astronomy is very basic at this point, so a lot of things were being, a lot of motivation to conduct observations was trying to tie in the movement of heavenly bodies, whether it's a planet, the sun, the moon, the eclipses, and the movement of the stars, to have some meaning for an individual in their everyday life, personally, or if they did that for someone else. But astrology is still much stronger than the science of astronomy, I think, to a certain extent. It's certainly something that's probably understood a little bit more by a larger group of people, whereas astronomy and mathematics, pretty much I get the impression that it's primarily in the venue of the scholar. It's not something that the everyday person knows or understands. There may be an application in their life, but they certainly don't understand it at this point. Okay, moving on. El-Mahrithi. Here again, this is the first time we move out of the Western or Southern Asian sphere. El-Mahrithi was an Arab Muslim astronomer, chemist, mathematician, economist, and scholar in Islamic Spain, Moorish Spain. Pretty much at that time, he was born in Madrid, he died in Cordova, so he spent his whole time on the Iberian Peninsula. And, basically Islamic Spain was called the Al-Andalus. Pretty much included everything in the Iberian Peninsula with the exception of the Pyrenees Mountains to the north, moving into the area of the Franks. Certainly incorporated the entire peninsula for the most part, at least initially during this time period. He founded an original Andalusian school of astronomers. That was the first. And he was one, he was one of the first individuals in this particular area to make his own astronomical observations. So whether or not he was expanding on the work, he was certainly conducting that and not necessarily relying on prior works done by astronomers that had preceded him. A couple of other things here again. Like I say, most of these gentlemen took to adding to the work of Ptolemy and trying to improve it. In this case, trying to improve the use of the astrolabe as with respect to formulating the positions of the various, heavenly bodies, particularly in the solar system. Enhance the astronomical tables of Rosmi, who preceded him by a few hundred years, and began, organized scientific research in the Al-Andalus, here again, the Iberian Peninsula. And in this case, I talked about one individual. We actually have suspect, this isn't based on hard information, but there is one story that he might have had a daughter by the name of Fatima de Madrid, who also became an astronomer. No other note with respect to that I was able to find. Okay, now we come to Omar Khayyam. You'll see something. I've got a couple of slides, 3 slides on Omar Khayyam, and I'll get to what he's probably more well known for. And it was something I found kind of fascinating. But anyhow, Khayyam was, active towards the end of the 11th into the 12th century. He was a Persian polymath, math, astronomy, philosophy, and poetry. And we'll see an example of that. Born in Nishapur, which was the capital of the Seljuk Empire, May 18th, 1048. And this is kind of interesting. And the reason I put this date in here, like I say, a lot of this specific information, has pretty much been lost. We have a rough idea when these individuals were alive. But the derivation of Khayyam's birth date actually comes from an astrological reading that was done. And it was done at the time during his birth, where Khayyam was attributed to have been born under Gemini, with Mercury rising or doing something. And looking back, individuals were able to, post date it and determine he was probably born on the 18th of May in 1048, whatever calendar was being used at that time. Anyhow, this was not necessarily an individual that came from, in this case, aristocracy or advantages that some of these other folks had. His ancestors were tent makers. They were tradesmen, although that is somewhat of an elevated position probably in this particular civilization with respect to those that worked, those that made, and then those that ran things. His scholarly capabilities were identified early in childhood by tutors, and that provided an opportunity for him to obtain an education with some more advantaged individuals. He was able to partake of that. Some of the things that Khayyam accomplished: developed an observatory in Isfahan, led other scientists, and we're starting to see more of this too, where some of these individuals aren't just working, and not that I suspect Ptolemy necessarily worked by themselves, but we're seeing more and more evidence where we have people working in the astronomy field, here again, not doing really sophisticated astronomy, but starting to work as teams, or starting to work with more than just themselves, running groups, leading groups. But anyhow, he led scientists in the revised Persian calendar based on precise astronomical observations. Whether or not they enhanced some of the observations that had been made prior, or they did their own to check it. But this work was, completed towards the end of the 11th century. And here's the case, I mentioned it before, where the calendar was developed. It pretty much remained in use in that area around Iraq, in the Persian area, up through the 20th century. He was able to calculate a precise solar year and designed a solar calendar with a precise 33 intercalation cycle. Intercalation cycle refers to the adding of, in the case of our calendar, adding a leap day in every 4 years. We certainly know with our 365, the year's a little bit longer than 365 days. And he was able to design a calendar that took this into consideration over a 33-year period. It was very accurate. And then he died back in, I think it's pretty much where he was born, in 1131, 83 years of age. I'm still somewhat amazed, and I certainly mentioned it when I was talking about Ptolemy, but it seemed as though a lot of these individuals went well beyond their years with respect to probably what the expected life was for a male or female during this period, given the lack of probably the health practices and the medicine that we have available today. But he lived to be 83. And of course, here he is. Yeah, he was a polymath. He was an astronomer, but his big thing, of course, Khayyam is probably more well known for his poetry. Particularly one piece that has been now referred to as the Rubaiyat. It wasn't called that back then, but scholars today have put together some of his works and have put it together in what they call the Rubaiyat. That was more than likely, most of the works were compiled in the early part of the 12th century. And I just included one stanza here because it does make reference, and you see the reference to some, the idea that Khayyam was probably involved in astronomy. And it's just a sample. It's from an opening of one of the works, quatrains, which is basically a stanza of 4 lines. And that's what you have here, one quatrain that appeared in the Rubaiyat. Okay, getting on. We're moving back to India again. Bahura was an Indian mathematician and astronomer. Here again, born into a family of scholars, so certainly an advantage here. His education, some of the work that he would do later was pretty much foreborn by the fact that his family was already of a scholarly type. He led an observatory in Ujjain. Works focused primarily, here again, math, planets, and spheres, which is one of the, with respect to astronomical work, was one of the big things, trying to model the planets, the sun, and the moon. We're still stuck with a geocentric model that has not changed up to this point. So most of these astronomers are still, working off of Ptolemy's basic theory, basic idea that the center of the universe is, the Earth, and everything revolved around Earth at that time. Anyhow, he was able to accurately define a sidereal year, and he died pretty much in the city where he created his observatory. Al-Tusi, pretty much during the 13th century, he was pretty much a fairly accomplished individual, another Persian polymath, architect, philosopher, physician, scientist, and theologian. He was born in the city of Tus, February 18th of 1201, excelled in learning and scholarship. Here again, not someone who necessarily had the advantages of some of his predecessors. His father, passed early in his life, so basically it was the understanding his father, passed on an understanding to his son that he wanted him excel in life and wanted him to learn to obtain a proper education, what was available. Anyhow, he championed for the establishment of the Rasad Khaneh Observatory in Azerbaijan. I think there are still remnants of it around today. It lasted for quite a while. Created highly accurate tables of planetary motion. And here now we start to see, some thoughts with respect to belief in heliocentrism rather than geocentrism. Why? Didn't find a basis for it. No understanding why Al-Tusi started to see this kind of an influence. I don't think it was necessarily something that necessarily passed on to Copernicus, but we can see we're getting, we're only about 200 years away from the time that Copernicus was born. So that was the last one. Basically, just summarizing, these are some of the things I talked about. Most of these astronomers were Indian and Muslim polymaths, with the exception of one being from the Al-Andalus, pretty much all the Indian and Islamic world in Western Asia. We're starting to see development of institutions of learning, schools, observatories, working in teams. And, there was a lot of building upon previous works, a lot of building upon Ptolemy's work. And in some cases, as we move through time, we see some of these individuals were actually building upon, work performed 200 or 300 years earlier. However, in a lot of cases, and even in the case of Ptolemy's, we see a loss, loss of the written records. In this case, they would have been scribed down. We've got basic printing that's starting, back at this time, but pretty much it was block printing. It wasn't movable type printing. And of course, that's what's probably restricting some of this work from being carried any further. I mean, certainly we get to the end of the 13th century. We've got, couple hundred years, and then we start to see movable type coming in, and of course the telescope a short while later, almost a short while after that. And of course, then that's when we start to see a lot of changes because the telescope enhances observation. And of course, at that time, we've also got a movement away from, the geocentric idea of thinking, and, the Copernican model with respect to a heliocentric, at least solar system, for that matter, not necessarily right from the beginning, because whether or not the sun was the center of the universe or the center of the solar system, up to that point, until telescopes started seeing improvement, we didn't see much change. Anyhow, we've got a couple of pages of references on each. And thank you for your time. Any questions, comments, or otherwise?
Yeah, well, I would imagine these guys lived long lives because they didn't have to go out and work in the fields and stuff like that. I would imagine.
Gus, that's actually a good point. And, because some of them were actually, they actually were born into, more comfortable lives. A couple of them were associated, if they weren't aristocracy, associated with it. But then, the type of lives they had to deal with. But still, I just find it kind of amazing that some of these, and even going looking at Ptolemy, he made it supposedly 70 years, which I think is pretty amazing. But no, you're right. That's a good point.
Keep it.
Well, there were a number of people who lived to old age back then, but the only reason that surprises us is that the reason the life expectancy was so low is that there was so much infant mortality. Yeah. And so when you average in the ages, it all comes out really low. It's like if you go to South Africa today and the life expectancy is 47 years, and you go, yikes, why is everybody dying so young? And it's not bad. It's just that a lot of people are dying of AIDS.
So you still find a lot of 80 or 90-year-olds.
One other thing to consider is that Arabic culture, especially after the fall of the Roman Empire, was generally considered a more advanced than much of Europe was, because they fell into the Dark Ages. So they generally had better organized, cleanlier cities than most of Europe. And so we're basing a lot of our life expectancy off of what we consider with medieval Europe, where everyone's just like, hey, Black Plague, I'm dead.
Yeah.
So with how they organize their culture, that life expectancy is a little bit more expected than you would expect for Europe during the same time period.
That makes a lot of sense. Thank you.
And with that, Pete, can you go ahead and toss it back?
Yeah, I did.
Yeah, I'm gonna
go back to you.
Gonna try to get this to work. Hopefully. So share screen. Cool. So this is going to be a little bit of an awkward setup for me. We'll see how it goes. Hopefully it'll work. So what I'm going to be talking about tonight is operating and just general navigating and using the Celestron hand controller. Can everyone see my screen? You should be seeing Google Chrome right now. Get a confirmation there.
Yeah, you're good.
Yeah, we can see it.
So this is a hand control. For those unfamiliar with telescopes, there are generally two types we use as amateur astronomers. One is the German equatorial, which is what's pictured here, and another, which is an alt-azimuth. And generally, some of these hand controllers will work the same. They may have some slightly different buttons on them in terms, or their alignment procedures will slightly different. Another thing to also keep in mind is that the Celestron hand controllers change over time. Some buttons move, some menus will change, and it kind of really depends on when you bought your telescope, when your telescope was made, and some other factors. So this is kind of intended as like a pretty good idea of what to expect, but there may be some differences on your own Celestron telescope if you do have one in terms of finding things. So I do recommend that if you do double check with your manual. It is a very good, very well laid out manual in terms of how things function. And they do a good job of explaining some of the settings. And now to kind of get in. And so I actually, I don't have a webcam. So what I'm actually doing here is I'm using my camera that I use for astrophotography, and I have it pointed at my table on a tripod, and I'm using the photo capture software I use in order to just kind of, jerry-rig a webcam. So if things look kind of weird, that's kind of what's going on here. Put this into full screen. Let me know if you can all see this. If you should be seeing a picture of a white sheet of paper. Okay.
Yep.
And it should be full screen. You shouldn't see any other menu bars or things like that.
Right. Yeah.
Okay, cool. I didn't know if Zoom was going to pick this up correctly because it gets kind of weird. So let me adjust some focus here a little bit. So once you first power on the hand controller, you get greeted with this general menu that's just basically saying press enter to start. I'm going to go ahead and do that. Now, if you've just bought your telescope, and then it'll ask you to basically put your mark on a couple of predetermined index marks so that when you go and start pointing into the night sky, it can get kind of close to certain stars during alignment. So we'll just go ahead and enter through that. And now we're at a screen where it's asking us to enter a date and a time. Now, if you've just purchased your Celestron telescope, you'll actually get another screen that's going to ask you a couple of options. One is for setting up your location and your time. Now, you can choose between a predetermined city. So if you're like in a large urban area, you can just generally select, say, Phoenix, for example. I don't know why you would do astronomy in Phoenix because it's so bright, but you could. I generally prefer custom site, and this is what I would probably recommend for those who are at CAC and Tampa. If you do use the club astronomy sites, you actually don't have to change the custom site if you go between the two. They're close enough to each other in terms of location that the 10 arc seconds you're going to drift across the Earth's surface isn't going to make that much of a difference when you're aligning your telescope, especially for visual astronomers. If you are doing some astrophotography like I do, even then I still haven't noticed much of a difference in terms of precision. I just normally, once I've set the custom site, I've just left it as is. So you can, in a custom site, you're entering your latitude and longitude, and mine are both set up right now for the rough position of Tucson. I think I actually have it set to Tampa within a couple of arc minutes. So it's just setting up, your latitude and longitude, which we have here. Setting up, and then we go into the time information. Since the majority of us are here in Tucson, you just want to go ahead and we'll pick USA Mountain Time. Especially if you're in a time zone that experiences daylight savings time, I would probably recommend using Universal UTC or Universal Time Coordinated, so that way you don't have to worry about flip-flopping the clock back and forth every time daylight savings time happens. But with Mountain Time USA, we can just set the clock here. I'm not going to do that. And we can choose between standard time or daylight savings. And go ahead and just power through that and the day of the year. And to kind of skirt back through, so those are the options you would get if you're powering your telescope up to your first time, to kind of go through that whole thing again, repowering up my scope.
Yeah, if I may add, Celestron also sells a module that's a GPS receiver that you look into the auxiliary input, and it gives you all this information and knows exactly where you are and all that at the time. Which I got when I bought my mount. It came as a freebie. So there's
I have that as well. I have that as well. I kind of got annoyed and frustrated with it, mostly because it would take like a good 3 minutes to find a GPS signal, and I got tired of waiting on it when I could just look at my phone and enter my GPS coordinates. So there is that. It depends. So again, this is going back once if you're returning your telescope again on the second night, you're not asked to input your location again. It's just kind of assumed like you haven't changed, or it hasn't changed significantly. Like if you're traveling between CAC or Tampa, but if you're like going from Tucson to the Grand Canyon for the Grand Canyon Star Party, you just have to hit the back button and you get back to that custom site screen to go back and enter in. I'm going to skip through all of that. Enter in your date and time. What often I end up having to do with my controller is I will have to come back in before my observing sessions. I will come back in and reset the clock just to make sure it's accurate to within 1 second. Mostly just because I do astrophotography, and sometimes it'll drift between like the month that I've used it by like a good 5 or 6 seconds, sometimes up to 15. And from there, we get to the first barrier that most people will have when they first buy a go-to telescope, and that is the alignment screen. One of the things I do strongly encourage people to do kind of before or as they first pick up any go-to scope is you kind of need to know where some of your bright stars are throughout the year. This is mostly because you're going to have to pick their names from the alignment screen here. And if you don't know if your scope is actually pointed at the right star you're looking for, you're not going to get a successful alignment, and you're going to be very frustrated with yourself, being like, why can't I see Andromeda here? There's just nothing but black. So I do strongly recommend, definitely learning where some of your bright stars are, Arcturus and Teres and so on. Over time, you'll get kind of a catalog list of alignment stars that you'll use by the season. I have an observing book where I write down every time I go out and set up my telescope what alignment stars that I have used, so that I can quickly refer back to them next year instead of having to be like, oh boy, I can't see. What did I? Having a handy list of alignment stars that you've written down over time certainly will help speed you up. In a celestron scope, we have a couple of options for alignment, and my hand is starting to hurt because of how I have to. I'm basically hugging my tripod so I can grip this controller and keep it inside of the camera field of view. So we have a couple of options for alignment. We have 2-star align, 1-star align, quick align, last alignment, and solar system align. So starting with some of the more simpler ones, for those of us who do engage in star parties and things like that, solar system align is designed for you are aligning on a planet in the solar system or the moon. Just you're not dealing with, you don't need a lot of high precision for those objects. You just want to get your telescope kind of sort of close. So if you are, supporting a star party event, you say, I just want to get to Jupiter. It's kind of bright out still. There's not a lot of guide stars, but hey, I can see Jupiter. You can use solar system align to just go straight to get a rough idea of where Jupiter is and continue on during that day to kind of get yourself going through. I won't demonstrate that one tonight. Just go where it has. We have quick align, which is it's very similar. Actually, no, rereading over my notes as I do this, I should start with the 2-star align next. So 2-star align and 1-star align are a little bit are the main modes I use. I normally use 2-star align, where it functions by you start your alignment, you hit enter, and it'll ask you to pick 2 stars, or if you're doing 2-star alignment, followed by a series of additional calibration stars. And the 1-star alignment is, the opposite of that. Instead of picking 2 stars on one side, and you'll pick 1 star on one side. So it starts out, you'll say, we will pick 2 stars on one side of the meridian, in this case, west, which is denoted by the west, the W, in the top right-hand corner of the display. You can change that by, I think it's hitting menu, where you can then swap it over as you want to pick alignment stars in the east in the beginning. You do have to kind of set that before you go through the alignment process. I just default to west. I'm just so used to it at this point, and I kind of forgot that switching that existed until I was rereading the manual to prep for this presentation. So it'll ask you to go and pick some stars. It has a pretty big catalog. One thing that is kind of a little bit interesting is sometimes you'll have stars in the night sky that you can clearly see. Typically when stars are kind of in a setting position, like for example, Arcturus is in a setting position. So when I was coming out here last night, Arcturus was my default, was what the hand controller was defaulting to. And now it might not even appear in the hand controller. So sometimes, even though you might see stars up that you could align on, they might not be available in the hand controller anymore for various reasons. So yeah, so here is Arrakis and Ascella, and Arcturus is no longer available for me, even though it was earlier in the night when I turned my telescope on. So you kind of need to keep that in mind as the season shifts. The stars available in the hand controller for the alignment will also change with you. So you kind of got to just be prepared for that. And sometimes if you're not used to that, just making up stars on the fly. So it'll ask, I'm going to actually go to something a little bit that's not going to move my telescope too much. Can't do Antares either. Arcturus, what do I want? Can I do Nuncke? Come on, Nuncke. So Nuncke is one of several calibration stars I use that's in the constellation Sagittarius, which is kind of at a setting position right now. So I'm just going to go to it. As I mentioned, my telescope is on, so I don't want to have the motors engaged too much because I don't have any weight on it, and I don't want to do anything bad to the gears. So you may hear it slewing right now during this time. I'm just going to give it a second. So it will slew to where it thinks Nuncke is. It's taking a bit longer than I expected. And in the normal process of using your scope, you will be looking through an eyepiece or through your camera alignment software and making sure that you're getting that star as close to the center of your field of view as possible for better alignment. I'm just gonna, and it'll first ask you to look through the finder scope. If you're pretty close, you could generally skip past this and go straight to the eyepiece. Sometimes your star will be aligned actually in the eyepiece and not in your finder scope. So I typically will be checking the finder piece first to see where my alignment is rather than relying on the finder scope. If I don't see it in the eyepiece, then I go to the finder scope and align it around there. So this first option is saying, hey, go ahead and use your alignment buttons here, these 4 arrows, and kind of push your scope so that the finder scope is looking at the star, and then press enter. And then it is going to ask me here, okay, so now that you put it in your finder scope, put it inside of your eyepiece, and then hit the alignment button, and that will go ahead and add that star to your alignment. And then we will do that process again for another star. Hold on to this. Give me 1 second. And we'll kind of repeat that same process here, picking that star, getting it in the field of view for the finder scope and the eyepiece. Skipping past those again. And then now that we've entered the 2 stars, we will have to add a calibration star. So these stars, the calibration stars, will be on the opposite side of the meridian from whichever you started on. So if I were to hit enter here, it will ask me to select up to 3 new stars on the east side of the meridian, because I originally started out on the west. And it will help increase the accuracy of the telescope pointing. Depending on what you're doing, if you're photography, I do recommend adding at least 2 other guide stars. If you're visual, you sometimes don't have to do this depending on what you're doing at that night. Generally on weather conditions and activities like again, star parties, you don't want necessarily need to go through it. But the same process of this here will be the same as what I just showed. Select a star, put it in the finder scope, put it in the eyepiece, move on. But I'm going to hit back so that I can skip out of adding calibration stars. And the other 2 modes that we kind of mentioned, that was the 2-star alignment. 1-star alignment is the same, except that instead of picking 2 stars first, you pick 1. And then quick align is similar to a 2-star align, but instead of using the scope, it models the sky in the hand controller. I haven't ever actually used quick align, so I'm not familiar with how accurate it is. I would definitely only be using quick align if I was doing something visual. just because for astronomy or for photography, you really need that extra precision, which is why I normally always use 2-star align. And then the other option, which I can't show right now because I did get past the alignment screen, is last alignment. And last alignment is really handy. It's for if you're out in your observing session and let's say you accidentally someone unplugs your equipment, you lose power to your telescope or your battery dies on your scope or something like that, and you have to swap it out. Last alignment will allow you to go back to your alignment for whatever you did. So you don't have to go through that whole, pick 2 stars, pick 2 more stars and go. You don't have to realign it again during the same night. It is recommended that you only use last alignment during the same observing session. Don't try to use last alignment if you're observing across multiple days, and that sort of stuff. So continuing on with alignment before we move on, if we hit the align button here, we can at any point during our observing session change what alignments, that's too high up, sorry about that, what alignment stars we used. So this is for the situation where you're going into a long observing session and your original alignment stars are shifted a lot in the night sky. Sometimes your pointing accuracy will change. Objects won't necessarily be in the center of the field of view again. So you can go and find new alignment stars in the hand controller during your session. It works the same way. Hit alignment stars, and then you can actually, it'll say, gives you an option to pick which stars you want to replace. In that case, Stunky or Line, and hitting back to get out of that screen. And same thing with calibration stars. You can, and we have calibration. In this case, I didn't add any calibration stars, so it was asking me to add them. But then another option that's hidden underneath alignment, which I think is only there for equatorial mounts. I'm not sure if the alt-az mounts has it. There's a little feature called polar align. For those that want a lot of extra precision, polar alignment is actually really helpful. What it does, and I won't show, is it will, before you pick polar align will show you 2 things. It'll say how far off you are from true celestial north on the hand controller. So your mount is able to kind of calculate this, which is really helpful. But it also has the ability where you can use a process to pick a star to help align your scope to true celestial north. Now, the way this works is underneath here, we have, if we see down here, we have the stars menu. So we want to go pick a star. In this case, I'm just going to leave it on Altair, but you could choose oh, hold up. My lens shutter closed, so it canceled the live preview. There we go. Where was I? So triggering polar align. So you will, before going into the polar align screen, you'll actually want to move your telescope to the star you want to polar align on. In this case, it's going to go to Altair. So then I'm going to get back out of the star alignment screen, which I got through by hitting the star button here. And I'll go into polar align and choose align mount. It's going to show me some scary warnings. You kind of want them in certain parts of the sky. It'll give you some warnings. Keep your stars off the horizon. You keep them off the horizon by about 15 degrees. And also as well off the meridian, because this is a German equatorial and it doesn't really like the meridian all that well. But we'll pick some stars to do polar alignment on. I typically do not use, if I used a star during my 2-star alignment process, I will not use that star during polar alignment. I will choose another star based on, where something is in the night sky. And it'll go through this whole pick a finder scope, put in the eyepiece thing that we did with the others. But then once you do that, going to sync it. So I've said, hey, here's Altair. It's got to remember its position. And then I'm going to hit enter to start the alignment on this. So it'll slew the telescope to where Altair would be if you were on true celestial north. And then you will actually use the RA and deck adjustment knobs on your telescope mount. You won't use the arrow buttons here on the hand controller, and you're going to gently nudge your scope so that Altair is in the center of your field of view, and that will help you put your telescope on true celestial north. And it works out quite well. I'm going to hit cancel out of that. So any questions so far on some telescope alignment procedures in terms of like what your alignment options are, and that anything of that nature? I know I might be talking a little bit quick here.
Hey, Connor, what year did you get that controller?
2017.
Okay, so it's a recent one. Okay.
Yeah.
I have a question. I have a Orion right now with the alignment thing on it, and I'm getting a Celestron. I've inherited it, so I mean I know with Orion that gives you like an alignment score, so you know how close you are to an actual alignment. Does this give you something similar, or is it just kind of?
So that's what's underneath the polar alignment menu. It tells you. So if this was on true north, adjust my focus here real quick. There we go. So if my telescope was on true north or very close to true celestial north, the azimuth and altitude here of my telescope would all read zeros. So this tells me my polar alignment error. So right now, my telescope thinks it's 1 arc minute off in azimuth and 18 arc minutes off in altitude.
Okay.
So it may be similar to that, but it actually tells you your error. I'm not owning an Orion hand controller or a Meade controller. I can't speak to either of those in terms of what they provide. That's why this is focused on Celestron right now. Certainly do welcome other people wanting to talk with the hand controllers for the other vendors. I'm certain some of our club members would love to have that.
But the Orion, it just boils it down to one number, and it's like if it's less than 1, then it'll work okay, and if it's more than 1, it's like do it again. But that's better that it does it like this. Yeah.
But that's why I really like the Celestron's polar alignment feature, just because it does help out quite a lot. Although sometimes I think it tends to lie once you complete it about the numbers, because sometimes it'll be like you're perfectly on polar, and I'm just like, but how do you know when? So it's kind of a mystery about how Celestron is able to know how much you moved your telescope to get to true north. Especially since you're not engaging any of the motors during that period, because you're physically adjusting knobs, not the motors. So in terms of that, I'm not sure which one would be better. I typically have had really good results with the polar alignment feature, so I'm more used to it at this point. And it also is, especially because doing polar alignment techniques can get really annoying this is actually significantly faster than doing some of those techniques, or if you don't have a polar alignment scope on your camera. So moving on a little bit, let's see, double check. So I did locations, some alignment procedures. Double checking some of my notes real quick so I remember where to go next. Where is that? There's one more thing I wanted to talk about in terms of alignment before we move on. Where is it? I don't use this all that much, but it's still something worth mentioning about. So there is, for those of you who are lucky enough to have your telescope mounted permanently in a fixed location, There is a really cool option. So underneath menu, inside of an option called utilities, there is an option in here called, where is it? Hibernate. So this allows you to put your telescope in a parked position. So some people will, instead of leaving their telescope inside of their observatory facing straight up, they will lean it out so that it is flat on its side, so that it's horizontal instead of vertical. And with Hibernate, you can tell your tell Celestron, your scope, your mount, that is the position you are leaving your scope in. And it will remember when you power off your scope, it will maintain its alignment for you and do some other really cool things. And then once you power up the telescope again, it's kind of like putting your computer to sleep instead of powering it on. There will be an option where you can tell it to wake up, and it'll put your telescope back into its last alignment, and you can continue on with your learning session. Can't really demonstrate that here over this, just for the sake of time. But nonetheless, that option is there, and it's definitely something that you would want to know about. So we're going to move on next to some of the catalog options that are available. Depending on, and this is kind of where the buttons on the scope get a little bit more important. Again, some things have changed over the hand controller. Typically your controller will have a couple of different catalogs on it. You can see on mine, I have solar system, stars, deep sky, and a little option called Sky Tour. We'll talk about Sky Tour here in a moment, but for the first three stars, first three ones, we have solar system, stars, and deep sky. So solar system is exactly what it sounds like. I'll get out of this menu, go back. It'll allow me to pick objects within the solar system, such as Jupiter, Saturn, basically the planets and the moon. It unfortunately won't include some other objects. You'll never see comments in this. For those of you who are comment hunters, you won't get much help on your hand controller. You will have to enter RA and DEC coordinates, which I actually need to remember how to go do. I
believe it's under menu.
Yeah, I'm trying to remember where it is under menu because I don't use it all that often. But we'll get to that in a second. But so it won't show things like Ceres or anything in the asteroid belt, any comments. It's just purely the planets and the moon. It will also show the sun, but you have to. But for safety reasons, Celestron disables that by default. So you do have to go on and manually turn that on. Check your manual for how to do that. Excuse me 1 second while I have a drink.
Yeah, and it only lists you the planets that are up in the sky. So I don't think you see Mars on there because Mars isn't out, I believe.
Correct. So in any of the catalogs, this goes true for solar system, stars, or deep sky. Your telescope, by default, you can tell it not to do this. We won't go into that, but it will only show you things that are actually up above the horizon. You can actually tell it a threshold so that it won't show things in the night sky unless they're 10 degrees above the horizon. You can configure that inside of your hand controller. I won't show that menu off during this, but that capability does exist. You can specify a limit for how high something needs to be to appear in this menu. So that it was how you, well, that's deep sky. So solar system will allow you to get to any of the planets or the moon. Then we move on to the stars catalog, which will show you a variety of ways to go and find stars. You can search for stars by constellation. It'll give you a list of some interesting double stars, by names, by the name of the star, which I use this more than the constellations because it's generally easier to search through. Hitting up and down a whole bunch on this hand controller does get quite tedious when searching for stars. and the named catalog and the constellation catalog, because you have to scroll to a constellation and then scroll to a star or scroll to a star. And those can be quite big, up to a couple hundred entries at a night. And some other options is we can actually pick from other star catalogs. So for those who are probably doing double star observing or variable star observing, you can choose from the several other catalogs like the SAO catalog, asterisms. I do know that there are some other versions of Celestron will have different star catalogs as well, in addition to the SAO catalog. So in terms of, and the general way that these work is you just, if it's a catalog that you have to know a specific number, you'll hit enter and it'll say, go ahead and enter the digits for the particular object, in this case, the SAO catalog number. And then from there, we can go on to Deep Sky, which works kind of the same as stars. You get a list of filters to search like named objects, such as it'll show, for example, the Andromeda Galaxy, the Pinwheel Galaxy. Actually, what else is up? So Andromeda, Barnard's Galaxy, the Bode's Nebula. Where is that one? So it's the Bubble Nebula, and some other interesting ones that you maybe know by a more common name, especially in the NGC catalog. If you're more familiar with, if you know it's a named object but don't know, but it's not in the Messier catalog. You can choose from the NGC catalog, some other galaxy catalogs like Able, the Caldwell Deep Sky catalog, and some other objects. Normally, I'm sticking to the Messier list or the NGC list. Occasionally, I'll drift into the Caldwell. But for most of what I ever want to do, some of these other ones, like the IC catalog, CCD objects, and the Able catalog, those are going to be objects that aren't really for visual observing. They're very much photographic targets. But they're also very difficult and very faint photographic targets. So I typically don't bother with those catalogs. I'm mostly in Messier or NGC or the Caldwell catalog. And so they work the same way as star alignment we mentioned. Let's go to Messier. So I can enter my Messier object, like for example, Messier 16. And then once I hit that, I can hit enter. Where's 016? So Messier 16 is also known as the Eagle Nebula. So you could, if you know the catalog number, you say, hey, this is Messier 16, you could just come here. Or you say, hey, I know it's the Eagle Nebula. My throat. And I could get through the same object through the named objects catalog. And I can hit enter, and it'll stew my telescope to that object. Yeah, it's the same for that. Now, for those who do visual observing, you're sometimes a little bit more adventurous. You might just be moving your scope through the night sky. And you might spot something a little bit interesting. In which case, there is this handy button on most of the scopes. Its position will change, but it's called Identify. That's not what so you'll put from where your telescope is pointed at. You can search specific catalogs. So right now, I'm going to go to NGC. So most of the NGC. So your telescope it knows the rough right ascension and declination that your telescope is pointed in. So if you're stumbling across the night sky and you're like, hey, there's something interesting here, I don't know what this is, you can hit this Identify button and you can have it point through certain catalogs. Like I just told it to go search the NGC catalog, and it'll try to find what objects are within that field of view. It goes up to, I think, about a degree away to give you kind of options, because there's some really big things in the night sky, like the Heart and Soul Nebula, for example. And it'll spend its time. I probably shouldn't have done NGC, but it'll search through. Give this a little bit more. How am I on time? I cannot see what climate is. It is almost 8 o'clock. Okay. So I'm going to try to wrap this up in the next by 8 o'clock. That's my target here. So it's going to finish this search. And it'll present a list of viable options that are in that area. As you can see, we get quite a few here. If you're expecting to see well, it'll only show catalog objects in one user. So you won't see this, even though some of these are like, for example, 6611 is going to take a really strong guess and say that's the NGC catalog number for the Eagle Nebula, as well as its other name, Messier 16. But so you won't necessarily see the pretty names. So you will have to cross-reference some of these with like another catalog, like a star atlas or a star chart that you have handy with you. But it may give you a pretty good idea of what you're pointing at. And then the last option that we have for finding things in the night sky, for those who aren't necessarily familiar with what's up there and are kind of just like, ooh, show me some pretty things, we have a sky tour option, and it'll present a list of objects that you can go through. Some of these are stars like Edicas and Sciapiscia and Mars. Those are stars in the constellations Cassiopeia and Pisces, respectively. Some Messier objects like Messier 103, M101, which is a pinwheel galaxy, and some others, and kind of give you an idea of some things you might want to go look at if you're not familiar with the night sky or any of the catalogs that we use. So it's a good way also to just kind of explore if you're still learning much about the night sky. Any questions so far on finding objects to go point your telescope at within the hand controller?
So, Connor,
Mhm.
I've got a probably what's a way older hand controller, and hardly any of these buttons are the same. But I hadn't really noticed that my telescope would keep itself within what's available in the sky. You know, like sometimes I'll ask it to go to something and it'll take me down below the horizon.
So that since you have an Altaz K, to my knowledge,
Yeah.
that's not necessarily that big of a position. Did you buy yours used or brand new?
I bought it used, and I think it was built in like 2001, and then I had to get a new hand controller because the old one died, and then they replaced the whole motherboard on the thing. So I don't even have any instructions on how to use it, but I know how to use. So it's kind of hard to know.
If you know the rough year, you may be able to go to Celestron's website and find the manual for your particular hand controller. What I suspect is going on is that in the utilities menu, there, give me 1 second here. Where is, so need to, I want utilities, I'm trying to find out where the menu option is. So underneath utility, I believe this is the right one. So if you go into menu, and underneath utilities, there is home position, factory settings, scope setup. I passed it. In mine, it's underneath home position, calibrate now. Where is it?
Well, mine
scope setup.
don't necessarily have the same thing.
So scope underneath menu, scope setup, and then filter limits. So this
Okay.
is the menu where you can tell it the maximum altitude. My case. Sorry, let me back out of that to show that for the beginning. So underneath menu, there you have utility scope setup and some other options. So it's, in my scope, it's underneath scope setup. It might be in a slightly different menu. And then there's filter limits. So this is where you can specify the maximum altitude and the minimum altitude. In my case, this is set to go from 10 degrees off of the horizon up to zenith all the way.
Okay.
So your scope might be set so that that is disabled. Let me double, because I think that's the menu. There's like several menus related to RA and deck. And I'm not sure I'm telling you the right one.
So is there a way, I was wondering if there was a way to, if you know the RA and deck, you can find something?
So if you know the RA and deck, that's what the identify function.
Yeah, see, I don't have an identify button.
That might be a newer thing that they added
Yeah.
onto certain hand controllers. So the identify button might not be there for some models.
I tried
Yeah.
going to the menu. I think it's under menu because I used
Yeah.
that.
Yeah, it's under menu and it's go to RA
Menu.
deck.
Oh, okay. Oh, okay.
So that's
Oh,
no,
okay,
so
there it is.
no,
You
so go
just
to
stand
RA
up.
and deck is for if you know the RA and deck coordinates, it will take you to that object. Kay's
Yeah,
question
that's-
is, if I know the RA and deck, how do I know what it is?
Well, I was wondering if I could go to an object if I knew the RA and deck. So I
Yes,
guess
yes.
I can.
Yeah, I
but-
misunderstood your question. So
Yeah,
yes,
but-
then underneath menu, there is an option. It's the underneath the main level. It's called go to RA and deck. Oh, and the identify menu also appears underneath there as well for me. So both of those, mine has a button for identify conveniently here. You may have an identify menu as well underneath menu. Learn something new tonight. And then precise go to. I am double check to see what that one is.
What is that?
Like I said, some of these are. Well, in the interest of time, since I've never used precise go to, I'm gonna skip over it because it's probably not something you're gonna want to go use. Please read your manual in the interest of time. But you'd be looking for, if you know the RA and deck, which is this is how you would use it to go find comments, is if you would have to look up the RA and deck that night before, and then go to the RA and deck specifically. And that's where this is. It's hiding. Thank you.
And Connor, what type of mount do you have?
It's a German equatorial.
Okay. There's some added features when you have an ultra azimuth and a smaller scope.
Yeah. So that was kind of the big caveat I put at the beginning. Depending on alt-az versus German, you may have slightly different options, even on Celestrons made in the same year.
Yeah, that's why I asked the year too, because with the alt-az, there's different alignment methods. They have a sky align where you just have to find three prominent stars, point it. The database, if it's in the database, based on initial setup, the telescope will know where it's at and use three prominent stars and self-align. And
then all of this changes if you get the Celestron StarSense hand controller, which does its own thing. So your alignment processes will differ slightly between the two scopes. But the general gist is you have to pick stars and know where they are. And for a lot of people, that's the very first hurdle is, well, is this
under the sky line, you don't have to know the stars at all.
Yeah, mine is like that. But before Dean up at Starzona changed my whole motherboard out, it was, I used to have to pick out the stars and then it would say slewing to Vega or something. And now I just pick whatever bright objects in the sky I want, even planets, and it aligns off of that.
Yeah, because you can pick two stars in a planet, not knowing that it's a planet, and it will align off that on the skyline. It'll tell you what it is when you go back.
It'll tell you what it is too. Yeah. And then it works really well.
So another option I want to run into specifically for German equatorial folks is underneath menu. And it is underneath scope setup. there is a an option here called RA limits. So depending on how much weight, sorry, that's not in the field of view. So it's already scope set up. There's RA limits. So what this option does is German equatorials do not like pointing at the meridian. It causes problems with them. So this allows you to say, tell your telescope how far past the meridian or it should track. So you can tell it if you are, continue packing 10 degrees past the meridian or stop tracking 10 degrees before the meridian. Because you're in an equatorial mount, you're going to have to do a meridian flip, or you may be concerned about weight balancing on your scope and maintaining that balance. So within the controller, you can tell it what those limits are. And you can, so that it doesn't go too far past, or you don't end up having your scope motor go too far past it. Now your telescope is banging into your mount. Another very useful option. And then there's one more. And then another really useful one, which I only found out here very recently, is in addition to RA limits, is it the meridian approach? Home position, blah, blah, hibernate. Sorry, double checking this remote because I don't use it all that often. So yeah, it's meridian. So what the meridian setting does is if you are trying to point to objects that are near the meridian, on, like, for example, on the east side of the meridian or the west side of the meridian, but they're about to pass over, you can tell it, your telescope, to say, hey, if this thing is on the meridian, go ahead and start out on one side of the meridian. So like if your star is straight overhead, you can tell it, hey, approach this so that my telescope is on the west side of the meridian, so that instead of me having to do a meridian flip in 5 minutes, it's already there. This setting was gold mine for me, just because of with me doing photography. I didn't have to worry about like, oh, this is going to be on the meridian in 20 minutes, and then I have to flip and realign and all this other jazz. So this was actually a really useful setting once I found it for helping me do longer imaging sessions. And I think that's kind of the big ones. There's a couple of other calibration menus for backlash, periodic error correction, things like that. But those are kind of more advanced, so we won't go into those with the time remaining. And also for those of us who are going into the South Hemisphere, there's some additional settings for you there, but I don't think any of us fall into that category here. So we'll skip over that. Cool. So that's kind of all the big ticket items. And that just canceled. So any questions, anything that you have about the hand controller that maybe I can try to answer?
Hey, Connor, not necessarily something regarding the function or the buttons, but flip your controller around.
Like upside down 180 or 90 degrees?
No, turn it so the buttons are facing the way. No, the other way. So the buttons, I can't see the buttons. I want to see the backside where the cord goes in.
Oh.
You had any problems with that? I try to be as, oh, yours is different. Okay. Yeah, that's a better construction. It's a lot more robust. My controller isn't as good on the back, and as gentle as I try to be with it, I've had some separation from the seal. So that's all.
Are you talking about where the cable meets?
Oh, there. Oh, I can't see. Is it? Can I see yours? No. Yeah.
Yeah, mine's coming out as well.
Okay.
It's one of those things that you I actually still have the. I would just get for you probably a phone, another extension cable. Mine's still on like the default old phone cable, so I don't get a lot of play, which is part of why this presentation is kind of a pain for me.
So
yeah,
that makes a lot of sense.
If you get a little extension cable, you don't have to do. Well, if you're really active, most of the time I'm mine's sitting on the stand right on the scope, so I don't have to care too much.
Yeah, that way I wouldn't have to, yeah, that would make a lot of sense. Thank you.
Any other questions? Cool. In that case, thanks everybody. I hope you actually got something out of some of the functionalities in the hand control that you may not have been aware of. Gonna go ahead and turn this all off.
That was good. Thank you.
Thank you.
And
Yeah, thanks, Connor.
stop share.
Yeah, just as a side note, what I did on my controller is I put a piece of Velcro on the back, and then the corresponding sticky part of it on one of the weights, so that I don't have to be hanging it, or so it's just not hanging there. So I just grab it and stick it on the Velcro, and it stays there. So that helps it from being flopping around all over the place, or me kicking it when it's dark and I can't see it. So
Yeah, that only works
just
if
a
you
little
have
extra thing.
that only works if you have a German with an alt-az mount, like I think like Kay and Pete has. It's a little bit more difficult to find a spot to put the Velcro. But I also think that
Yes.
that for alt-az mounts, the hand controller has a mounting bar on the alt-az bar
It
itself.
does, but it's
It's
barely long
really
enough.
hard to use.
Yeah, it's barely long enough and it gets in the way and it's problematic, and that's probably why my
Slides
cord's
out all
got
the
beat.
time.
And I think an extension, because basically it's just a phone jack that goes into the base of the mount. So I
That's
think
a
I'll
good
just
idea.
buy an extension, just
Mhm.
another foot, okay, because that's all I need. I mean, if I had that, that would be fine. Then I wouldn't have to worry about, especially when, I'm moving, say,
Well,
100 degrees in azimuth. That's where it gets
Gus's
problematic.
feedback is really more so on some of the scopes, there's like a little clip that attaches to the telescope bar, and you slide your hand controller into
Yeah.
that, which
Yeah,
can get
yeah.
kind of annoying to find. So that's why Gus just took Velcro and slapped that on the weight, so he doesn't have to keep finding it every night.
Yeah. Yeah, if you see the picture there, it's on that weight that I have down at I have the piece of Velcro there, and then on the back of the controller. So I just reach over and boom, plop it on there, and it stays there. And I don't have to, because the little bar, or the little handle or whatever it is, it sits on one of these legs of the tripod.
Yeah.
So if I'm on the other side, I have to go reach around. But if it's up front, it's easy to just grab it and do it that way. So I thought, hey, I got a piece of Velcro. What can I do with it? Oh, I know what I can do with it. So that comes in handy.
And we're going to wait 10 years when we can talk to our telescopes and we don't have to push buttons anymore.
Well, that'll take all the fun out of it, won't it?
No, the fun's observing, Gus. I mean, punching buttons, I know, well, especially, after you get to learn the sky a little bit, I'm still learning, but it's just this idea, sitting there, adjusting your eyes, taking the glasses off to get up to the eyepiece and putting them back on to play with the controller. And
Yeah, one of the things I found was finding the stuff was half the fun. It's like,
yeah,
it's like going hunting. Half the fun of going hunting is finding your prey. So once you get it and you shoot it, it's like, okay, now I got to carry it out. So same thing with astronomy. I think half the fun is, okay, I got to find it between these two stars. Where is it? Oh, there it is. Okay, next. That type of a thing.
So for next month, I do have a volunteer for doing Gerard Kuiper, but I don't have any other presentations lined up for the month for a main topic. Does anyone have any? Did moon craters? So we had some other ideas, and I know I'm not sharing my screen anymore. For a couple of objects, but someone had asked in the past for binocular targets. I thought we had done that already. I know we had a binoculars presentation a couple years ago by Bill, but it wasn't
Yeah,
on.
he's gonna be doing it this Saturday.
Yeah, he's a really good binocular observer. But in terms of binocular objects, so I don't actually have anyone lined up So if anyone's willing to volunteer to do a presentation for next month to fill that out, by all means, please let me know. If not, I'll try to scrounge something up together at the last minute. And
Okay. Oh.
with that, I'm going to go ahead and I want to go to